Hello everyone, my name is Chitra Nevtianingsi. My ID number 410142108. Okay, so in here I'm going to make a video about problem in everyday life related to optimization problem to maximize or minimize. So in here I choose the maximize problem. After that I will solve the problem by using graph method and the line of inquiry through GeoGebra application. Okay, this is the problem about PT Angkasa Jaya, and the question of the problem is how to determine the number of units of each type of product to be produced every day so that the profit can be maximized. And the mutual needs of product unit of raw materials and labor can be seen in the following table. And this is table. The table is to the simplify of the previous problem. So with the table we can understand easily. After that, the steps to solve the problem. The first step is decision variable, and X is kilogram of raw materials and labor hours of silk fabric. Y is kilogram of raw materials and labor hours of wool fabric. After the decision variable, we conclude the objective function. The objective function is z equals 40x plus 13y. The objective function is format in million, but to make it simple, too easy to understand, so it write like that. After that, the constraint. We decide the constraint. The first constraint is 2x plus 3y less than or equals 16, and the second constraint is 2y less than or equals 13, and the last constraint is 2x plus y less than or equals 40, and x comma y is greater than or equals 0. So after that, after the constraint, we can get the solution of the question with the GeoGebra application or GeoGebra web. So I'm going to open the GeoGebra first. Okay, we are in GeoGebra now. To solve the problem, at first I'm going to write the constraint so we can look at the visible region or visible area. The first constraint is 2x plus 3y less than or equals 60. Next is 2y greater than or equals 30. And next is 2x plus y less than or equal 40. And I will minimize. So we can see this is the visible region or visible area. To make it clearly to look and make it easier to understand, so I will change it with equals. And equals. And this is the area, and when we want to look the visible region, we can gather all the constraints and we can look at the visible region. Okay, 2x plus 3y less than or equal 16. We use n 2y less than or equal 15 and 2x plus y less than or equal 14, and also x greater than or equal 0, and y greater than or equal 0. I'm sorry, y greater than or equal 0. X greater than or equal to 0. Okay, and this is the visual region. Okay, we can determine the every point in on the visible region. The first is, we know this is 0, 0. A. The second is B, and this is C, and this is D, and this is E. We know there are the 5 points of 5 vertex A, B, C, D, E, and actually we can substitute each of the vertex to the objective function, but when we substitute it one by one, it will take a long time. So to make it quickly, we can use the ruler method point. Like we can use this letter and name. This is we can change with the random alphabet, and the minimum we decide is 0, the maximum 1000. Okay, after we determine the slider, so we can write the objective function for tx plus 13y equals to is a, so it's a. After that, we can change it, so we can see this inquiry line. So if we move the slider to the right side, the value is more bigger than before. So we can determine the maximum profit. So we can know the number of each unit when the profit is maximized. At first, to point A is 0. Point E is around 4,150, and the point D is 750, and point B, we can see the point B is 80, and point C, the point C is 900. So we know that the value on when the value of the objective function is maximum is on point C. So we know the point C is 15,10. So we can conclude that the number of each unit when the profit maximized is 15 and 10. So we can solve the problem with GeoGebra. And after that, we also can prove with the table and substitute one by one the result is same, because we already know the answer, but we can answer to the another way. Actually it's same, but it more take a long time. Okay, this is the constraint, and this is the first constraint, second constraint, and third constraint. So we can determine the point with the table like that. After that we know, and this is the result of the GeoGebra. Actually we can grab it, not just GeoGebra, but it's gonna be like the manual way. So we can determine the vertex like same as before, like A 0,0, B 20,0, C 15,10, D 7.5 and 15, and E 0,15. After that, we substitute the of point to the objective function. We suppose this is in million, but to make it easier, so it makes the simple one. Look at this point. This is the maximum point, and we know that the maximum profit is in the point C, which is in here. So we know the C is 15,10. So the conclusion is, in order to maximize profit, the number of unit of product produced each day is 15 unit of silk fabric and 10 unit of wool fabric. Okay, that's all for me. I'm already finished to solve the problem with GeoGebra in query lines, so we can find the answer to the problem. I'm sorry for my mistake, and see you.